In the name of Allah, the most gracious, the most merciful. Praise be to Allah, and peace and blessings be upon the Messenger of Allah, our Master Muhammad, and upon his family and companions altogether. Now, after finishing the general discussion in the first episode and talking about topic in second episode, we start with you a new episode, a new challenge, and practical information that will benefit you in the job market about Let's start with a new and very important point that has a significant impact on the performance of CT, which is the burden. So what is the effect of burden on the likelihood of a CT becoming saturated? Do you remember what burden is? As for the burden test, burden or load is defined as the value of the resistance present in the secondary circuit when applying the rated secondary voltage. Skanda-yult. VT burden applies to CT. Lower CT burden is better, needing less capacity. Digital relays have lower burden than others. High burden risk, CT saturation. Burden is key in CT choice. A lower burden on the CT is beneficial, reducing the need for a high capacity CT. Digital relays have less burden than static or electromagnetic ones. As burden increases, terminal voltage rises, nearing CT saturation. Burden, including wire and relay resistance, is crucial in CT selection. We upgraded to digital relays, replacing. As the burden increases, the voltage across its terminals rises, nearing the knee point, indicating potential CT saturation. Thus, burden is crucial when selecting a CT, including wire and relay resistance. At one station, we upgraded to digital relays, removing electromechanical ones. Post-upgrade, we advised no CT change was needed as the CT handles high and low burdens. Another key factor is ensuring the CT's knee point exceeds the secondary terminal voltage with the relay connected. This sometimes affects CT change decisions, adding unnecessary costs. We were consulted about CT changes for the new digital relay. We advised no CT change was needed as it handles both high and low burdens. The CT's knee point must exceed the secondary terminal voltage when connected. This influenced CT change decisions, sometimes adding costs. CTs are for protection or measurement. Protection CTs have higher knee point voltage. This prevents quick saturation during fault. Ensure the knee point value is higher than the secondary terminal voltage with the relay connected. CTs are for protection or measurement. Protection CTs have a higher knee point voltage than metering CTs to prevent quick saturation during fault. Protection CTs operate over a wide current range, unlike metering CTs, which need accuracy within a limited range. Consequently, metering CTs are characterized by their... The CT is used for protection or measurement. Protection CT has a higher new point voltage than measuring CT. Protection CT operates over a wide current range, unlike metering CT, which is limited for accuracy. Protection CT has low accuracy, so during faults, 10,000 or 9,000 amperes make no difference. It has high saturation voltage and can transfer large currents to the relay. A CT usually has multiple cores, 1, 2 for metering, 2 to 4 for protection. There are no higher investigations, no stronger investigations, and no cleaning investigations. While protection CT is characterized by low accuracy, it doesn't make a difference during a fault moment whether it's 10,000 amperes or 9,000 amperes, for example. It also has a high saturation voltage and the ability to transfer and convert very large currents to the secondary side and then send them to the relay. Generally, a single CT contains more than one core. Typically, 1 to 2 cores are used for metering, while 2 to 4 cores are used for protection. The revival of a nation indeed.